Hi, physics class. This is the video solution to the fourth problem in our Newton's second law problem worksheet. This problem talks to us about an elevator, and there's a cable supporting this elevator. It's 1,500 kilograms, and the cable has a maximum strength of 21,750 newtons. The problem asks us for the maximum acceleration that the cable can give the elevator without braking. Well, the first thing I want to mention here is I don't want you getting too hung up where you see things like where it says maximum. We'll just ignore those for the moment. It just comes into how do you make your answer at the end, where you're telling it's a maximum or a minimum. So like other problems like this, I always want you to do a free body diagram. So we're going to draw our box, and let's draw our forces. Right? We know that our force here, our first force here is gravity, right? And we also have the force due to our cable, and it's pulling in the opposite direction. Now we're going to use our free body diagram, right? Because we need this to do our calculations. So to find the maximum acceleration, we need to find the maximum net force. So how are we going to find that net force? Of course, we're going to use our free body diagram, and we're going to add up the forces to get our F net. So you just literally look at your free body diagram, and you're going to add up the forces to get your F net. We do that, we're going to see that the equation we get, our net force, sum up our forces, there's our F cable minus our F gravity. Now I subtracted gravity because it's pointing down, right? Down is our negative direction. So our net force is going to be our force of our cable minus the force of gravity. What's our force of gravity here? Well, it told us it was a 15 kilogram elevator, and we know the gravity is 10 meters per second squared. So our force due to gravity is 15,000 newtons. Our problem tells us that our cable has a strength of 21,750 newtons. We got to subtract the force of gravity, that 15,000 newtons. That tells us that our net force is 6,750 newtons. Now that we know what our net force is, now we can use Newton's second law, and we could say, well, we know that our second law tells us that F net is equal to acceleration times mass. If we rearrange that and solve it for acceleration, it tells us our maximum acceleration here is going to be our net force divided by our mass. We just calculated our net force, 6,750. They told us the mass was 1,500 kilograms. That's going to result in 4.5 meters per second being our maximum acceleration. Now notice it says maximum, right? So it said the maximum strength was 21,750 newtons. If that number got bigger, if our maximum strength got bigger, that would mean our F net got bigger, which means our acceleration would get bigger. So that's what I'm saying, the maximum, don't get distracted by that. It'll fall out here at the end.